Problem. Find the directional derivative of 2xy plus z square. This is the function. At the point 1 minus 1 3 in the direction of I plus 2j plus 2k. This is the given vector. This is not unit vector. Then here this is the function at the point 1 minus 1 3. Let here phi is given. Phi is equal to 2xy plus z square. This is phi. Then here this is the vector, given vector. That is, given vector is denoted as A. Given vector is I plus 2j plus 2k. Then listen, another formula for directional derivative. Directional derivative. What is the formula for directional derivative? Directional derivative is dou phi by dou x into u1 plus dou phi by dou y into u2 plus dou phi by dou z into u3. Or another formula is directional derivative is equal to del phi dot u. Del phi dot u. What is del phi? This is the gradient of phi dot u. U is the unit vector. That is, first we find del phi. Here phi is given. Del phi is equal to, what is the formula for del phi? I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z. Listen, that is equal to I into, what is dou phi by dou x? Differentiating phi with respect to x. Differentiating this phi with respect to x. That is 2 constant, y constant, derivative of x is 1 plus derivative of z square with respect to x. So z square is constant, so 0. Plus second term j into dou phi by dou y. Differentiating with respect to y. 2 constant, x constant, derivative of y is 1 plus z square. Differentiating with respect to y. So z square is constant. So 0. Derivative of a constant is 0. Plus k into differentiating with respect to z. 2xy constant plus derivative of z square is 2z. This is del phi. Then del phi at the point 1 minus 1 3. That is del phi at the point 1 minus 1 3. That is, put x equal to 1, y equal to minus 1 and z equal to 3 in del phi. That is equal to, listen, 2y. Here 2 into y into 1 is 2y. So 2 into y is minus 1. 2 into minus 1 I plus 2 into x. X is 1. 2 into 1 j plus 2zk. 2 into 3 k. That is, listen, here minus 2i plus 2j plus 6k. Minus 2i plus 2j plus 6k. This is del phi. Then unit vector. What is the unit vector? Vector divided by modulus of the vector is the unit vector. So vector divided by modulus of this vector. What is the coefficient of I? It's 1. 1 square plus coefficient of j 2. 2 square plus coefficient of k is 2. 2 square. That is I plus 2j plus 2k divided by 4, 4, 8 plus 1, 9, root 9. That is 3. So, listen, the directional derivative. Here the unit vector is equal to I by 3. Here root 9 is 3. I by 3 plus 2 by 3j plus 2 by 3k. This is the unit vector. Then directional derivative is equal to del phi dot u cap. Then del phi is equal to del phi is equal to minus 2i plus 2j plus 6k dot this unit vector u 1 by 3i plus 2 by 3j plus 2 by 3k. Then find the dot product of these two vectors, that is equal to here minus 2, this here the coefficient is minus 2, minus 2 into the coefficient of I is 1 by 3 plus multiply the coefficients of j, 2 here 2 into 2 by 3 plus multiply the coefficients of k, 6 into 2 by 3, that is equal to minus 2 by 3 here plus 4 by 3 plus 12 by 3, that is equal to 14 by 3. This is the directional derivative. That is, the formula is del phi dot u cap. Del phi, here phi is given. Then we find del phi. What is del phi? Del phi is the gradient of phi at the point, given point. Then find u cap. U cap is the unit vector. One vector is given, then find the unit vector of that vector. That vector is u cap. Vector divided by modulus of the vector. Then take the dot product of these two vectors, del phi and u. Del phi dot u cap. We get the directional derivative.